of you that sort of know a lot more about these things probably didn't. There's only been 5 like confirmed observations of that bird, so probably was a different kind of thing. Okay, so here's a much more boring representation of what I just showed you. So in this plot, so there's 2 bars for each month throughout the year. This was in the year 2010. The white bars correspond to an absence observation. The black corresponds to a presence observation. So what that means is that each of the observations in black here means that someone said I was here and I saw a bird this time. The absence can mean 2 different things. Either someone says I was here and I didn't see this kind of bird, or it can just mean that I said I was here and I saw a different species of bird and I just didn't say anything about this species. Okay. So they sort of make this assumption going into it that if you don't say you did see this kind of species of bird, then it means that you were there and you didn't see that kind of species of bird. Okay. So for every species you see an overwhelmingly higher number of the white bars than you do the black bars. And so this just sort of changes the interpretation of things. But it's an important thing to take into account, because there are certain people that do this, that they only go out looking for one particular species of bird or another. So, okay, so that's what the raw data looks like, and this is what the confidence intervals look like when we use a bag procedure or sub-bag procedure like I was talking about. So you can see it follows the same sort of general pattern. So in the winter we see almost none, and then as we get into the spring and summer we see the same sort of overall pattern that we saw. So there's something about this that's really nice, which I want to point out, which is that in the winter where we're pretty sure that we're not going to see those birds, not only are the confidence intervals saying we think that you're going to see 0, but we're really, really sure that you're going to see 0. Okay, so they're much, much narrower in the months where we're more sure about what's going on. And in the summer months, things are much more variable because we've got a lot of presence observations, a lot of absence observations. Okay? So the width is sort of actually reflecting what we really want it to reflect, which is the uncertainty in what's going on. Okay.
Did you go 50 after? Yeah. About 5.
Okay. Maybe I'll just stop with this and the next one. So this is, again, this same data set, but now we looked at the data not just in 2010, but over the course of several years, and the question was, is month playing a role in this? Okay? And we saw that it really should be, right? Knowing month should really help you to make a better prediction. And so there's an interesting thing that happens here. So this was just based on 20 randomly selected points. But so when we build one ensemble that uses month, and one ensemble that just doesn't use month, and we do that hypothesis test, we get something that's hugely significant, a p-value that's approximately 0. The interesting part of this is that when we build an ensemble that has a random version of month versus an ensemble that just doesn't use month at all, we still get something that's significant. Okay, now you can say, well, that's, it's 58 versus 4,200, so there's something different going on there, but this is still not something that you really want to see. But I'm a statistician, it's not something I want to see. And so the first thing that you might think of is to say, well, did we accidentally, when we just randomized the values a month, did we just accidentally define some pattern that's now being used? And so to check that, we can just, again, do another randomization. So in practice, this typically means just permute the values for that variable. So we can do one permutation, we do another permutation, and just test, okay, are there differences between 2 random instances of it? And we see that there's not, so that's not what's going on. And so the last test we do is really the test that's, I think, is most important, which is to say, when we build with the original true value of month versus some random version of month, do we still see it? And you can see that we do. So what this final hypothesis test is really saying is month significant for making predictions? And not only is it significant, but is it more significant than I could get just by adding more random noise into the model? Okay. So remember, our test statistic, what we're really measuring here, is how different those predictions look. So I can get things that look different by just adding in more random noise. Okay, and especially in the context of random forest, where you're already adding in some randomness. What you really want to say in practice is not just that this is significant, but it's more significant than I could get just by sort of adding in additional randomness on my own. Okay. All right, so I'll stop here, but this is, you see the same sort of pattern here. This this is actually quite the ongoing controversy at the lab. So this is the same kind of test, except this time we're testing year. So the original data was from 2004 to 2010, and here we're just looking to see, does year make a difference? So are these migration patterns, are they changing from year to year? And again, so you see the same sort of pattern. You see something significant. When we do a randomized version, still something significant. When we do two randomized versions, it's no longer significant. But when we do the original versus a randomized version, we still get something significant. So same pattern, same sort of results that we just saw. But not nearly as overwhelming evidence as you saw in the last case, right? I wish this was more definitive because this is quite the controversy of the lab. There were, when I showed them these results maybe a year or so ago, there were certain members that sort of went, well, do you really believe that? There's not actually a difference. And then other members would say, well, of course there's a difference. Of course they're not exactly the same year to year. So, so it's actually something, it's kind of a big ongoing problem. And it's something that's, prior to this project, prior to the whole eBird project, the only way to get any of this sort of information was to ask an ornithologist, well, how likely is it that a bird is in a given area at a given time? So there really isn't much other data to support one way or another this notion that birds are actually changing their migration patterns on a yearly basis. Good. All right, so I'll stop with that. So some brief bibliography of stuff I talked about. That's it. Thanks for coming. Yeah.
So the year, like whether or not a year is significant, could that be explained maybe in part by more observations, like more people actually use the system?
That's when we've done it a few different ways. So the first thing I would do is just to do it. Just take the data that's there and do it. When you scale it, sort of when you say like, okay, in years where we had more observations, let's just go fix sort of the smallest sample from each year, or for each year we have a given sample. So whichever one of those is smallest, we'll just take a random sample from the observation stream, so that everything is equally sized. And when you see that, you see essentially the same thing. So I don't think it's due to that. There's another sort of subtle issue here, which is also something that's a bit controversial, which is just that are the observations getting better or worse over time? You know, in years where you have more observations, is that actually better, or does that just mean that a bunch more people are doing it, which might mean that there's a whole lot more variability? You might trust a year where you only had 5,000 observations if those are coming from really, really good people, rather than 100,000 observations, none of which you know who they're coming from. So so it's yeah.
When you had the underlying uniform grid structure, do people use non-uniform grids as well too? I know some
You can. So I think you would always sort of use a uniform grid, I think, unless you had data that was sort of spaced weird. But what you can do is actually weight the impact of those points more in the hypothesis test. So if you have data that's sort of a lot more dense in one particular region, you might want to put more weight on the differences there.